In section R.5, we're going to look at rational expressions. Let's find the domain of the rational expression. We have x minus 7 times x minus 1 over x plus 3 times x minus 1. For these types of questions, you just look at the bottom. You just want to make sure that the denominator cannot be equal to 0, because we can't divide by 0. So I'll set x plus 3 equals 0, or x minus 1 equals 0. That's the only way that the denominators can be 0, is each of the factors equals to 0. So let's solve the first equation. I'll subtract 3 to both sides. X equals negative 3. And for the second one, I'll just add 1 to both sides. X equals 1. So we have two values that cannot happen because the denominator cannot be equal to 0. So our solution for this is the domain is x such that x is not equal to a 1 or a negative 3. So that's our domain, all of the values of x except 1 and negative 3. Example 2, write the rational expression in Low's terms. We have 12x squared minus 30x over 4x squared minus 25. Notice the top term, we can factor out the GCF. The GCF in this case is 6x, and that leaves us with 2x minus 5 on the top. And on the bottom, I notice that this is the difference of squares. This could be factored as 2x plus 5 times 2x minus 5. So this simplifies as 6x times 2x minus 5 on the top. And this is supposed to be a 2x plus 5 times a 2x minus 5. Notice that we have a common factor of 2x minus 5 and 2x minus 5, so we can divide those out. And our final solution is 6x over 2x plus 5. For part B, I'm going to factor the top. I'll use my x technique here. So we have negative 16 and negative 8. The two numbers that work are negative 4 and negative 4. And on the bottom, we can factor out the GCF of 2. This is 2x times 4 minus x. And let's double check. 2x times 4 gives us 8x. 2x times negative x does give us negative 2x squared. So that looks good so far. This factors as x minus 4 squared because we have x minus 4 times x minus 4 on the top. And you can just rewrite that as x minus 4 squared. On the bottom we have 2x times 4 minus x. Notice that these look very similar. I can actually factor out a negative from the bottom here and then rotate this around so it looks just like this. So we'll take that negative and we'll put that into the front. And so we have x minus 4 squared on the top divided by 2x. Again, I rotated this from the bottom because we factored out a negative 1. Now we can reduce the x minus 4 and x minus 4, divide those terms out. So we have negative x minus 4 over 2x. Now of course you can put the negative to the top if you want and then distribute it. And that gives us 4 minus x over 2x. Another option would be to put the negative in the denominator here with the 2x, but this looks like a good solution to me, so we'll leave it like this. In example 3a, let's multiply 6z to the 6 over 7 times 28 over 9z squared. First thing I want to do is just multiply across. That's how we do fractions, so we'll say this is 6z to the 6 times 28 over 7 times 9z squared. Now the next thing I want to do is factor this. I can factor out the 6 as 2 times 3. I can factor out the 28 as 4 times 7. We have z to the 6. I'll leave that on the top. On the bottom, I have a 9, which can be factored as 3 times 3, and a z squared. Now let's see what cancels out. I have the 3 cancels out with the 3, the 7 cancels out with the 7, and there are 2 z squareds down here, and that cancels out with 2 z's up here, which leaves us 4 left. So let's multiply that out. We have 2 times 4 times z to the 4th on the top. On the bottom, we just have a 3. I can simplify this as 8. So our final answer is 8z to the 4th over 3. In example 3b, I'm going to do the same process. We're going to multiply this across, but let's factor this using the AC method, and let's factor this using the AC method. Okay, so do that work on the side somewhere. We have negative 40 and 3 on the bottom. So the two numbers are going to be 8 and 5. This gives me a negative 5. And so the top can be written as 4n squared plus 3n minus 10. And I can write the middle as 8n minus 5n minus 10. We can factor out this as n times, or 4n times n plus 2 minus 5 times n plus 2. The top factors as n plus 2 times 4n minus 5. And we can do the same strategy here for the bottom. So we'll use the AC method again. We have negative 4 on the top. Again, 2 times 2. 2 times negative 2 is negative 4. We have 3 on the bottom. And the two numbers are going to be 4 and 1. This is a negative 1. So this factors as 2n squared plus 4n minus 1. And again, I'm splitting the middle. Minus 2. So let's do factor by grouping. This equals 2n times n plus 2. We'll take out a negative 1 here. That's n plus 2. This factors as n plus 2 times 2n minus 1. So this is a lot of work, but make sure you do the scratch work somewhere on the side and then replace these terms with the factored versions of them. So let's go back to our problem now and replace those terms with the factored version. This gives me n plus 2 times 4n minus 5 times 2n minus 1 on the top, and n plus 2 times 2n minus 1 times n plus 4 on the bottom. Notice the n plus 2 and the n plus 2, they divide out. And we have a 2n minus 1 and a 2n minus 1, they also divide out. They technically become 1s because the same number divided by the same number is 1. And so this results in our solution being reduced to 4n minus 5 over n plus 4. We're going to divide rational expressions. The first thing I want to do is change this division into a multiplication. Recall, if I'm dividing two fractions, a over b divided by c over d, we're going to keep the first one the same, change this to multiplication, and we're going to take the reciprocal of the second term. You learned that from elementary school, so remind yourself of how to divide fractions. So we're going to keep the first term the same, and then we're going to flip the second term. And the next process is going to require a lot of work. You need to be able to factor this term. This one's using the AC method. This term I'm going to factor using the GCF. It has a GCF of z squared. This one, we're factoring out a GCF of 6z. This one is just the x method. So let's try to factor each one of these. So we need to factor each and every single one of these terms. Here I can factor the bottom as z plus 4 times z minus 3. This has a GCF of 6z, so let's take out a 6z. This leaves us 5z minus 1. This one here has a GCF of 2z squared, so we'll take that out. That leaves us a z plus 4. Now here we can use the AC method. I can multiply 5 times 3, that's 15. We get negative 16 on the bottom, and the numbers that work are 15 and 1, but they both have to be negative. So I could split the middle here. So let's just do the scratch work on the side. 5z squared minus 15z minus 1z plus 3. This gives me 5z times z minus 3. I'll take out a negative 1 here. We get a z minus 3. This factors as 5z minus 1 times z minus 3. So I'm going to replace this with 5z minus 1 times z minus 3. So let's write our expression out. We have 5z minus 1 times z minus 3 over z plus 4 times z minus 3 times 2z squared times z plus 4 over 6z times 5z minus 1. So let's cancel out the 5z minus 1. 5z minus 1. The z plus 4's cancel out. And the z minus 3 cancels out. We have the 2 and the 6 also reduces. This reduces to a 1. This reduces to a 3. And the z squared and the z reduces. 1z cancels out with 1z. So we finally have our answer as z on the top over 3 on the bottom. For the top left here, I'm going to use the formula for the difference of squares. That's x squared minus 1 equals x plus 1, x minus 1. This one, x cubed minus 1, is equal to x minus 1, x squared minus plus 2x plus 1, and that's from the difference of cubes. So we have two different formulas for this. And notice here we have a 4-term polynomial. So these are going to require us to do factor by grouping. I could take out a y here. So that's y times x minus 2. I could take out a 3 here. That's 3 times x minus 2. You could pull out an x on the bottom. That's y plus 3. And here I'll just pull out a 1. So we pulled out a 1, we get y plus 3. This can be written as x minus 1 times x plus 1 over x minus 1 times x squared plus x plus 1. That's again from the difference of cubes. And then we can factor out the GCF for the top pair, the second pair, and then we'll do the same process on the bottom. This factors as x minus 1 times x plus 1 over x minus 1 times x squared plus x plus 1. We didn't do anything to the left side, but we did simplify the right side by taking out the x minus 2 and the y plus 3. And now we can see what divides out. We have x plus 1, x plus 1, x minus 1, x minus 1, y plus 3, y plus 3. So that leaves us with an x minus 2 on top and an x squared plus x plus 1 on the bottom. And that is our solution, x minus 2 on top over x squared plus x plus 1. So it's very important that you know how to do factoring for these types of questions. In example 4a, we're going to add fractions. We have 3 over 10z to the 4th plus 2 over 15z squared. First thing we want to look for is the LCD, the lowest common denominator. In order to do that, we'll have to look at 10z to the fourth and 15z squared and try to break those down into prime factors. We have 10z to the fourth can be written as 2 times 5z to the fourth. 15z squared can be written as 3 times 5 times z squared. And so the lowest common denominator is going to have the factors 2, 3. We only need 1, 5. And we'll take the highest power of z. So we'll take unique powers of 2, 3, 5, and the highest power of z to the fourth. That's going to give us our LCD. This LCD is a number that's divisible by 10z to the fourth because it contains 2, 5, z to the fourth. It is also divisible by 15z squared because it contains a 3, 5, and z squared. So that's our LCD, and we're going to use that to add these fractions. Since we have the LCD, now we know what we need to multiply to get the denominators the same. If you look at 10z to the fourth, we're missing a factor of 3. So I'm multiplying the top and bottom of the first term by 3. If you look at the second term, we're missing a factor of 2z squared to get our LCD. So we'll multiply the top and bottom by 2z squared. I'm multiplying the top and bottom by 3. And here I'm multiplying the top and bottom by 2z squared because we need it to be 30z to the fourth again. So let's do that and simplify this expression. We have 9 over 30z to the fourth plus 4z squared over 30z to the fourth. And now we can just add the numerators together and keep our denominator. This results in our solution. 9 plus 4z squared over 30z to the fourth. Be careful when you're adding fractions. Remember, you're just adding the numerators and keeping the same denominator. So don't change the denominator, keep that the same, and just add the numerators. This is our solution. 9 plus 4z squared over 30z to the fourth. In this case, we have 7 over m minus 5 plus 2m over 5 minus m. The denominators look very similar, but they're not quite the same. So I'm going to factor out a factor of -1. Notice that we can change the second term here by taking out the factor of -1, and that gives us -1 times m minus 5. So our LCD is going to be that m minus 5. We're factoring out the factor of -1 from the top and the bottom, which is equivalent to multiplying the top and bottom by -1. Notice that the negative gets transferred to the top, and the denominator here switches around so it's exactly the same, m minus 5 across. Now we can add the numerators together, 7 plus -2m on the top, and we keep our same denominator, m minus 5. So we get 7 minus 2m over m minus 5, or you could rewrite this as 2m minus 7 over 5 minus m, but remember they're equivalent. In this example, we want to subtract 4 over x minus 3 times x plus 5 minus 6 over x plus 5 times x minus 5. First thing I want to do every single time is find that LCD. So the LCD is going to have to be divisible by x minus 3. So I need an x minus 3. I need to be divisible by x plus 5, so we'll have to add x plus 5 to it. I don't need to add another x plus 5 because we already have it from the previous term. And I need to also be divisible by x minus 5. So the LCD is just x minus 3, x plus 5, x minus 5. Again, we don't need two x plus 5s because this is already divisible by both of the denominators. Now, we need to figure out what's missing on the left side here. We're missing an x minus 5, so we'll need to multiply this by x minus 5 on the top and on the bottom. On the right, we're missing an x minus 3, so we'll multiply that on the top and on the bottom. So again, we multiply the top and bottom by x minus 5 because that's the factor that we're missing to get our LCD. And on the right, we do x minus 3 on the top and on the bottom. I have to distribute this 4 to the top here, and then here we have a 6 that we have to distribute, but remember there's a negative in the front, so we should be careful with that. This results in 4x minus 20 because 4 times x is 4x. 4 times negative 5 is negative 20. I distribute the 6 to the x minus 3, that's 6x minus 18. Now notice this negative here, we're going to have to distribute that again, and then we'll simplify. So that gives us negative 6x plus 18. And of course we could collect like terms after that. The 4x and the negative 6x gives us negative 2x. Negative 20 plus 18, because we distributed, gives us negative 2. And this is our solution. Negative 2x minus 2 over x minus 3 times x plus 5 times x minus 5. For this question, we're going to use the LCD, and that's x squared. I'm going to use this to cancel out these fractions here, which I don't like on the bottom. So let's multiply by the LCD to all of the factors, and that is x squared. So we'll multiply that to the top and to the bottom. Now when we do that, you want to make sure to distribute it to each of the terms. This gives us 3x squared, and the x squareds cancel out, that's why we get a 4. X squared times 6 gives us 6x squared, and the x squared cancels out with this x squared, gives us negative 1. Now double check to make sure the top can't be factored and the bottom can't be factored, and that completes our question. In example 5b, I'm going to do the same technique. Let's find the LCD. I need a z plus 1. I need a z minus 1. I need another z, so we'll put that in the front. And then we already have a z plus 1, so we don't need to add it to our LCD. So if you're having trouble with the LCD, just take pieces of the denominator and don't repeat yourself. That's all you need to do to find the LCD. Just like before, I'm going to multiply this to the top and to the bottom. So let's do that. Let's multiply it to the top and to the bottom. We're multiplying by z times z plus 1 times z minus 1 to the top and to the bottom. Now we want to be extra careful when you do the distribution. We're distributing this to this to this, and this to this, and that. Now let's do the first part. We have z times z plus 1 times z minus 1. Well, we know that's going to cancel out with a z plus 1. And that will leave us with a z and a z minus 1 on the top. Let's do it again. We have z plus 1, z minus 1 times this thing. We're going to cancel out with the z minus 1s this time. And so we're going to have z and z plus 1 on the top. For the bottom, we know that the z's are going to cancel out. And so I have z plus 1 and z minus 1. And we'll redo that again. If we multiply this times the last term, well, the z plus 1s will cancel out this time, leaving me just a z and a z minus 1. So take your time, simplify it, see what cancels out. This gives us z times z minus 1 on the top, minus z times z plus 1, and then on the bottom we have z plus 1 times z minus 1, plus z times z minus 1. So now let's distribute and simplify. We have z times z, that's z squared. Z times negative 1, that's negative z. Negative z times z is negative z squared. Negative z times 1 is negative z. Over. Now I'm going to FOIL this out. This is the difference of squares. So I'm just going to use a shorthand technique. For the difference of squares, we can just multiply the first with the first. Z squared. 1 times negative 1, that's negative 1. Then I'll do this again, that's going to give me z squared minus z. Now let's simplify. Let's see if anything cancels out. Z squared cancels out with negative z squared. We have negative 2z on the top. We have z squared plus z squared is 2z squared. And then we have a negative z and a negative 1. And this is our solution. Negative 2z on the top and 2z squared minus z minus 1 on the bottom.